Well, Thomas tells me that Facebook and Instagram are down. That is a boon for productivity the world over, I think. File systems and disks, not to mention mental health. Much of an administrator's time is spent managing storage. This is a true statement. Depending on where you work and what's going on, you could have a period of weeks or months where 70% of your time is spent moving data around from one system to another in one way or another. Right? Data centers have petabytes of disk space, and a petabyte is 1,000 terabytes. So a lot of storage. What do we need? We need the appliance. Get clean copies. Let's look at CDs and DVDs. We don't use these physical CDs very often anymore, but we use a virtual CD, don't we? We use those ISO files a whole lot, mainly to install operating systems, but as admins, that's a pretty common activity. What we need to do is download a tiny ISO file. And we want to download it to our Mac or Windows workstation. Just click on that, save it. I've done that on my workstation. Now I need to go over to S01 and right-click on right-click on the border and select choose a disk file. Not anywhere. You need to click right on the ISO image. You can just barely see it in my W01. See where my mouse is? You want to right-click on that guy. If I right-click on it, you won't see it because it's a different window. I'm going to go over to S01 and insert the ISO into the drive. There we go. Let's go over to S01 and see what we can see. I don't see the CD, the DVD. The DF-H shows me all the file systems I have access to, all the ones I have mounted. I don't see the CD-ROM there, even though I put it in. We got to mount it. On a server especially, we don't want a file system, a disk we plug into the system to mount automatically. That could give us unpredictable behavior. And we want our server to be predictable, even if it means we have to do a little more work. We're going to make a directory to mount the file system, and then we're going to mount the file system on it. Windows is different from Linux and Unix in this very important regard. In Unix, we have one file system tree that starts at the root. Any file we can access by going /directory file. All the file systems are in one big tree. When we have a new disk, we kind of splice it into that tree. Windows can do that, but the default behavior in Windows is to give a new drive a new letter, right? CDE. In Linux, what we do is we make a place in the file system for it. Here's a directory called mnt-tiny. And I can mount my CD-ROM at mnt-tiny. Warning, device protected, mounted, read only. Does that make sense? Not like an error I should be worried about?
No, it's a CD that you can't write to, or DVD that you can't write to.
Why not? Because it's a file. It's just an ISO file. Why can't I write to the ISO file? I realize if it was a physical disk, I couldn't write to it, but it doesn't make sense to me that I can't write to it. Why can't I write to it? Bit of a trick question. The file system layout for the ISO file system, does not support changes. There's no way to, there's just no way to modify it once it's been built. Because it was designed for read-only applications. Let's take a look and see if we can see it. Right at the bottom, dev SR0. mnt-tiny. Well, wait a minute, that's weird. I asked to mount dev CD-ROM, but I got dev SR0. Let's take a look. ll/dev SR0. CD-ROM. Oh, what is the file dev CD-ROM? Anybody? You did this in fundamentals. So look back to fundamentals. Oh, Ryan, 2 points for Ryan. It's a symbolic link. Now, when we ask for dev CD-ROM, the OS goes, oh no, you actually mean dev SR0. I wonder what's in that directory. Find mnt/tiny. Not very much. A README file, a directory called bar, and a directory called foo, each of which have some files in them. If you were an administrator and you found this mounted on your system, or you found this ISO lying around, you mounted it just for curiosity, what file would you look at now? Would you start by looking at foo F1, foo F2? It could be, oh yeah, we've seen that before, haven't we? We've had readmes and install. Let's take a look at that README. Whoever made this ISO went to the trouble of leaving a README to tell us what it is. I think I can just cat it. This is a tiny ISO image file. Nothing terribly exciting there. Let us unmount. Is it truly gone? I don't see it there. If we do our find again, it's empty. Note the directory still exists. And when we mount files into the Unix file system, the directory where we're mounting the new file system must exist, or the mount won't work. Disk image file. We can make these ISO images. Makes sense. Somebody needs to be able to make them somewhere. Quick clarification. Unmounting does not remove the file from the disk, but it removes the disk from the file system tree, so we can't see it. So when you remove when you unplug a USB drive, the files aren't removed. They're still on the disk. You just can't see them anymore. In order to build these ISO images, we need a program called Gen ISO Image. Easiest way to install software? Our old friend, Yum. Install Gen ISO Image. That looks good. Yum's helped us out. It's actually going to install 2 packages. Got a little happy complete message. I think we're good to go. Let's use it. We're now going to build an ISO image file with the contents of the opt_mohawk directory. Might recall from the lab tour that opt_mohawk has books and some data files. This guy, ooh, that ran quickly. Lots of options here. The ones we care most about right now are -O, TMP mohawk.iso, and opt_mohawk. O often stands for output, and in this case, that's what it stands for. This tells me that when we're done running the command, we will have created a file called TMP mohawk.iso that is an ISO image of what's in this directory. Let's go. That was quick. Cool. To test to see if that worked, we need a place to mount the ISO. I'm going to make a place to mount it. mnt/dvd-test. This time, instead of saying mount dev CD-ROM, we're going to say mount the file at this spot in the file system. When we mount a file instead of a disk, we need to tell mount that it is a loopback. We say -option loop. And optionally, we can tell mount what type of file system to expect. Have you heard the term loopback before? I bet you have.
Networking?
And in networking, what's a loopback interface? Where
Like
does it point to?
localhost?
Pardon me?
Localhost, like right back to you?
Right back to me. Oh, this concept of loopback it's a computer science term. You'll hear it in a number of places. The loopback interface. Here we're talking about using the loopback option for mounting. Enough chatter. Let's see if it works. Same warning message. That looks, I think it went okay. And there we go. DVD test. It says it's 100% full. ISOs are always 100% full because there's no facility to update them or write to them. We'll notice that instead of saying it's a file, it's a device called loop 0. Hold that question about the device. We'll talk about those devices in a minute. Let's see what's in there. Books and data. Refresh our memory. What's in OptMohawk? Books and data. We've made a backup archive copy of the Mohawk directory as an ISO file that we could then email, burn to a CD and send, do lots of things with it. Now it's time to add some disks to our system. The system as delivered has one disk drive. That's not very common for a server. 2, 4, 16, 32, depending on the server, you can have a lot of disk drives. To do this, we need to add a virtual disk to the system, to S01. And we do that from the VirtualBox GUI. The server must be down in order to add disks to it. I'm going to leave that as an exercise for you. You've done the virtualization. I think you can add a disk. I've already added 2 of them. The disk, well, let's take a look at them. Where we see them in the operating system. LL/dev SD star. See what's there. LL/dev/SD star. This is going to show me everything in the dev directory that starts with SD. Here is our root disk, SDA. And here is our new disk, B, and our new disk, C. What do you notice different about SDA and SDB?
SDA looks like it has partitions already.
Oh, very good. You happened, whoever answered that, bonus, you know about how partitions work and how they get displayed in Unix. If you didn't know that, a good answer would be, well, SDA has these related files, A1 and A2. Every operating system I've ever dealt with has a way of taking a whole disk drive and breaking it up into smaller pieces. In the x86 PC world, those are called partitions. It's just a way of taking a disk and breaking it into pieces. In the case of SDA, if I do a df, I wonder if we can see any of those. Oh, look, one of them is SDA1 is mounted at boot. You might think that the root would be SDA2, but it's not. And the reason it's not is we use Logical Volume Manager to manage the disk for the root. We'll see about Logical Volume Manager a lot in the lecture and a little in the tutorial. For now, we're going to take SDB and make it usable. In order to do that, we should partition it. It is possible to use the whole disk without any partitioning. But partitioning only takes up a few bytes. And it gives us a way of telling the world what's on the disk. Usually we build partitions even if we only build one partition on a disk, like we're going to do with SDB. The fdisk utility shows us all the partitions when we use a -L. If we supply no arguments, it'll show us all the partitions on all the disks on our system. We see SDA, it's an 8 GB disk, and it has 2 partitions. One of them is a Linux file system, and one of them is Linux LVM. Kind of cute, right? The partitions give us a hint about what we're going to find inside. B and C are 8 and 2 GB respectively. Doesn't look like they have any partitions. That makes perfect sense. Here's the loop back for our ISO. And these guys are for LVM, this dev mapper, root, and swap. We'll get to LVM next. We want to take B and put a single partition on it. To do that, we're going to use the tool called CFdisk. I have also supplied a little YouTube video on just how to run CFdisk. CFdisk dev SDB. Be careful when you do this, because we could mess things up if we did the wrong device. What type? I want DOS. I definitely don't want CGI. That's Silicon Graphics, a Unix vendor. And I definitely don't want Sun, which was a Unix hardware company, is now a part of Oracle. Oracle bought them. I either want DOS or GPT. Either will be fine. DOS is older and simpler. Let's use DOS. Tells me that I've got free space. What are my options down here at the bottom? New, quit, help, write, dump. Well, I think we can all guess I want new to create a new partition. How big do I want it? It's offering to make it 8 gig. That'll be the full disk. That's what I want. So I'm going to say, okay, carry on. And I want to make it a primary. In the lecture, we'll talk about the difference between primary and extended. For our purposes, when in doubt, make it primary. Well, I created it. And it says it created it with a partition type of 8.3, which means Linux. I'm using Linux. It's a Linux file system. That's all good. I could quit, but if I quit, I will exit without saving the changes. I want to write. Are you sure you want to write this to disk? Oh, yeah, I'm so sure. The partition table has been altered. Okay. Now I can quit. fdisk -L dev SDB. There we go, one partition. We have a new device file. When we do our LL ls minus l dev sd star, that we have a new device file that was created just now. If we look at the contents of this device directory, there's quite a bit in there. These device files are one of the reasons we say everything's a file. In Unix, everything's a file. The way we tell the kernel what devices we want to use is to refer to the device files, the files in the /dev directory. When the system boots, the kernel inspects your hardware and builds the files in /dev. The dev directory, we as administrators generally don't create files there. The kernel creates those files based on the hardware config when it boots. Where are we? Okay. Before we can use that partition, we need to build a file system on it. In Linux and Unix, we talk about building file systems. If you're in Windows, what term would you use instead of build a file system, but it means the same thing?
Is it like initialize the drive?
Could be. That's one. I'm not exactly sure what would happen. That might also include partitioning. So when you do this, you have to pick what file system type. So when you do this, it's going to say, hey, do you want to make it FAT32 NTFS? Jacob got it. It's formatting. So in the Windows world, we talk about formatting a drive. Formatting a drive is building a file system on it. And building a file system doesn't do a whole lot, but it's essential before we use the disk for files. It just lays out the data structures, the basic the basic directory structure, plus it allocates some space for our old friends inodes. Maybe look back at your fundamentals if you don't remember what an inode is. Let's make it. Okay. Creating file system, 4K blocks. This tells me that whenever I write to the file system, the natural size of an IO will be 4K. That also tells me that the smallest amount of space that I can allocate on the disk for a file is 4K. And it created 524,000 inodes. What's the maximum number of files that I can create in this file system? Tricky question based on the number of, okay, go back to fundamentals. Every file has some data about it. Who owns it, when it was modified, where its data is on the physical disk, every file has to have an inode. If my file system runs out of inodes, I can't create a new file. Looking at this, there's no way I can have more than 524,288 files on this file system. That's a lot. I'm okay with that. If it wasn't enough, say we were doing some sort of a web server that stored a huge number of tiny files, we'd have to build the file system and say, when you build it, give it more inodes. Once it's built, the number of inodes is static. Let's see if we can use it. We made our file system. Oh, before we can use it, we need to put it in the file system. And to do that, we need a mount point. So we're going to mount it at /share engineering. And similar to how we mounted the ISO, we mount SDB1. This device file gets mounted at share engineering. Well, that looks pretty good. What do you think's on there? Wait, what? There's a directory called lost and found. Weird. I didn't create that. I'm pretty sure you guys didn't sneak in and create it. You can also see, though, that in the root directory, we don't have one of those. It's a little weird, actually. The root directory should have one. Every time we build a file system, a lost and found directory is created. What's in lost and found? Oops. Nothing. When we go to the section on checking file systems, a file system can become corrupt and need to be repaired. Not very often, because file systems are way better than they used to be. Back in the old days, it was pretty common. If your system crashed, you'd have some orphaned files, some files where there was data, but no directory entry. And when we check the file system, we need a place to put those. Well, we put them in lost and found. Let's make sure that we got this guy mounted. We'll use the df command. There it is. Boom. It's about 8 gig, and it's almost empty. Why is it not completely empty? The overhead of the file system, the inodes, the root directory, 1% of the file system has been used up already just for the overhead of the file system. That's enough of this file system. I want to get rid of it. Goodbye. Umount is short for unmount. Make sure it's gone. Yep, no more share engineering. To make the mount automatic every time we boot, we need to make an entry to the file called etc fstab. The file entry should look like this. what we're going to mount, where we're going to mount it, what type of file system to expect, any options to the mount. So here we could put something like read write or read only. Even though the file system is a full Linux file system and supports updates, we could still mount it read only. And if we mount it read only, not even root can write to it unless it gets remounted read write. So mounting something read only can be really helpful if you want to make sure that it doesn't get changed. The last two columns we'll leave for your research a little bit later. For now, under most circumstances, what you put there doesn't matter or matters very little. Let's put this guy in FS tab. We already have an entry for root. This tells me this dev mapper tells me I'm using LVM for root. We got a root file system on LVM. I have another file system on boot, and it's mounted not by a device file, but by an ID in the file system. So the mount command can go look at all the available disks and look for the file system that has this ID. And when it finds a file system that has this ID, it mounts it at boot. We're using LVM for swap. We also have an entry for our Red Hat ISO, which may or may not be in the drive when we boot. Look at the option that we gave for the Red Hat ISO. The option that we specify is no auto. When we specify no auto, the file system will not get mounted at boot, nor will it get mounted by the next command we're going to run, mount -A for auto. When we do mount -A, it walks the entries in the FS tab and then sees if they're mounted. If they're not mounted, it mounts them. Unless, of course, we told it not to. Oops. Let's go back here, get my, there we go. Mount -A, all or auto. Go through the FS tab and mount everything you can if it's marked auto. We mounted share engineering, but we skipped the Red Hat ISO because it's no auto. Okay. Questions about FS tab and the mount command? Let's recap. In order to add a disk using classic partitioning, which means not LVM, the steps are, and how did this numbering get so messed up? 1, 5, 4, 5. Oh, there's a problem with my HTML. I'll fix my HTML. The numbers will be better. My apologies. We partition the disk. We build a file system. we create a mount point, and then we mount it either interactively or through FSTab. If we mount it with the mount command, we'll lose the mount when we reboot. Sometimes we want that, not always. If it's a solid part of the system we want around, we put it in FSTab. So partition, build a file system, mount it. When we use LVM, there's one extra step, maybe two. We partition the disk, we add it to LVM, the logical volume manager. Then we create a volume and we use the volume. That seems like extra work, and it is. We partition, we do LVM, and then we build the file system. The old way, we just partition and build the file system. So more work. I don't like extra work. I don't know about you. I'm not willing to do extra work for nothing, nor are many Unix admins. There must be a reason for LVM to exist. There must be some things we can do with LVM that we can't do or are hard to do in another, well, with just basic partitioning. What does LVM give us? LVM gives us the ability to create partitions, shrink partitions, grow partitions, except we don't call them partitions in LVM. We call them volumes, logical volumes. A logical volume is a lot like a partition that we were using before. We can grow them, we can shrink them, we can create a large number of tiny ones or a few big ones. And here's a really cool feature of LVM. In LVM, I can create a volume which is bigger than a single disk. Not of huge value today, but still of some value. When LVM was created, disks were small. I mean small. Megabytes, not gigabytes, megabytes. So sometimes we needed to have many disks in one file system, and LVM lets us do that. A little bit of work to learn LVM, but it's really useful. A couple reasons. One, you're probably going to have to use it because that's what your system uses at work. It's worth using because it gives us some really useful features as an admin. Another sales pitch for learning LVM. LVM really hasn't changed fundamentally since I learned it in the mid-90s. So 90s, 2000s, 10s to 2000 to 10, 30 years. Give or take 30 years, it really hasn't changed. So learn it today, it's going to be useful for decades. Let's get to work. Add the disk, got it. Check that the new disk is visible. Should be SDC. I think we already did that, but let's do that again. SD, show me all the SDs. There's an SDC and only an SDC. No SDC1, SDC2. Tells me I haven't partitioned it, which is good. It's unused. I can partition it and use it. The lab tells me to format it with a single partition. Okay. CF disk dev SDC. I'll do DOS. It's all free. Cool. New 2 gig. The disk is 2 gig. Yeah, a 2 gig partition is going to use up the whole disk. Well, that's what I want. Make it primary. It says that its type is Linux file system. That's not exactly what I want to tell the world. I want to tell the world, should the world be interested, that it is Linux LVM. Now I can write that to disk. I do want to write it. And I'm all done. Now we have an SDC1. fdisk minus L dev SDC shows us that it's 2 gigabytes in size and claims to contain Linux LVM stuff. It doesn't yet, because I haven't done any LVM work on the disk. All I did is create a partition and put a label on the partition that says it should contain Linux LVM. Expect to see Linux LVM inside. These labels really are for the administrators so that we know what we should find there when we look. There are 2 LVM commands we need to use. Well, 3 actually. The first thing we do is PV create. The PV create, it stands for physical volume create. Simple, simple, see how fast it went? It just writes a little bit of data to the disk that says, hey, I'm being used by LVM. We're going to create a whole new volume group called VG Share. And we're going to put our disk SDC1 in that group. Successfully created. Then we create a 1 gigabyte logical volume named catering in that volume group. Did everything go to plan? Let's look at the volume with LV display. It's pretty good. It's 1 gigabyte in size. It's read-write. It's available. I can use it. Right? Let's start using it. This volume is used like a partition in the non-LVM scenario. That means I can build a file system on it. That went well. I can make a point for it to be mounted in the file system via directory. And I can put an entry in FS tab that will mount it every time we boot. You can use Nano, Edlin, any editor you want. I happen to like VI. This tells me I'm going to take the volume named catering from the volume group named VG Share and mount it in the file system at Share Catering. What type is it? It's an ext4. I'm going to mount it with the defaults. Don't worry about the later stuff. How do I get it mounted? There's a bunch of ways. The easiest way is probably to go mount minus A. Hey, there we go, share engineering and share catering. It was share catering we just did. And there it is. Beautiful. Remember when we looked at that lost and found directory? Well, that can be populated by a file system check. And the file system check utility is called FSCK, file system check. We can't do that on a file system that is mounted. The first thing we need to do is get the file system unmounted. It's gone. I'm convinced it's gone. Then we can use the FSCK command to check it. By default, it just does a really quick check. Yep, everything's good. We can also force a detailed check, even if it's marked as clean. There we did the default check. Yeah. SDB1 is empty, so the check goes very, very quickly. If the file system isn't empty, the check can take quite a while. Old file systems took a long time to scan because of the way they were structured. It could take 20, 30 minutes, an hour, 2 hours to boot the system if the system had crashed because it had to do with this file system recovery. We don't get in situations like that very much anymore. Even when the system crashes, the file system recovery is very fast today, but it still could run into problems. The reason these problems exist is that the data on the disk can be slightly behind the data on the server. Every time we write to disk, we first write to an area of memory called the buffer cache. Then the operating system, some very short time period later, moves the data from the buffer cache to the disk. If we crash in between it going to the buffer cache and being written to the disk, we can lose that data. If that data happens to be structural data about the file system can become corrupt. And it's even worse than that with modern disk drives. In order to improve performance, many modern disk drives do what is called, I want to write this for everybody, out of order writes. Without knowing exactly what out of order writes are, it's not a trick phrase. What do you think out of order writes means on a disk drive? It means that the disk drive controller does not respect the order of writes based on the time they were received or the order they were received in. So the host computer can say, write A, write B, write C. The drive controller can say, got it, got it, got it. The host thinks everything's on the disk fine. But in fact, the disk drive is caching to and waiting. So you said A, B, C, but it's more efficient to actually write C, A, B. So I'm going to wait until I've got a few more writes, and I'm going to go CAB. What this means is that my operating system thinks the writes went A, B, C. System might crash in the middle, and only C is on the disk. That's weird. The operating system would assume that if there's a partial amount of data, it's going to be A, B, and C missing. Could be C there and A and B are missing, because the disk drive will do things out of order. And SSDs do things out of order too. You'd think that because they can write anywhere, anytime, they'd never do that, but they do, because they have housekeeping of their own to do. It's rare to run into file system inconsistency problems, but it's still possible. You're ready to go. I suggest that you walk through the lab on your own, or if you've walked through it, followed along, and understood pretty well, but not 100%, a good idea might be to wait until you've seen the lecture tomorrow. You've seen the commands, you've seen the theory, then get going on your hands-on, or go through it now. It's all good. You'll have lots and lots of practice to type these commands in your career, let me tell you. Questions about what we did today?
That CF disk utility, was that kind of like a universal Linux tool that you can find on every flavor?
Now probably. What someone decides to put into their distro, I don't know, but pretty much everybody should have CF disk. Because fdisk, if I can type it correctly, fdisk is the old-timey one. And when we have a nice character-based interface on it, we call it CF disk. There are other utilities. GNU has one called gparted. But CF disk should be available just about everywhere.
Thanks.
You're welcome.